Good afternoon, Year 10. Hope you're all well and coping all right with these continually strange circumstances that we find ourselves. We're trying to soldier on though with the syllabus as best we can. Last lesson you looked at inequalities, solving equations with less than signs in or more than signs, etc. Today we're going to look at graphical inequalities. Now, this is a slightly different topic to the one from last lesson in that it's to do with lines rather than just equations with one unknown in it. Now, as you hopefully are aware, lines have two letters involved. Simplest line of all would be y equals x. Just show you what that looks like. There's the line y equals x. Now, what happens, so basically any point along that line has the same x and y coordinate, and that's what you should understand by y equals x. You should also understand that it has a gradient of 1 because there's a 1 in front of the x, and that's why for every 1 square you go across, you go 1 square up, etc, etc. If you drew a triangle on here and then tried to work out the gradient that way, say I drew a triangle there, I'd end up doing 6 divided by 6, which would be 1, hence the gradient is 1. You should also notice that it crosses at 0, the y-axis, and that's because it's plus 0 on the end. If I change it to y equals x plus 1, it will cross at 1, but it will still have a gradient of 1 as well. Hopefully, I'm just a quick refresher on straight lines and how they work. Now, this is not about straight lines as such. It's about regions that you get when you do the following. If I say y is greater than x, then all the area in blue is where I can actually be. So the area in blue is where I can actually be for y to be greater than x. So when it's a more than sign, you can be above the line, and when it's a less than sign, you are below the line. Let me just show you. There we go. So that's less than x is below the line, and I've shaded the region, well the computer program whatever has shaded the region where y is less than x, below the line there. So if I was to pick a point in here, say this one here, this is the point 6, 2, and clearly the y value is lower than the x value. The x value is 6 and the y value is 2. Whereas if I pick a point up here, then the y value is more than the x value. This is the point 2, 8. Therefore, the y value is more, so that's why it's not in the shaded region. So that's y is less than x. Also, you'll notice there's a dotted line on the edge. That's because y is not allowed to be equal to x. If I change it to a less than or equal to sign, then it will change into a full line rather than a dotted line. Okay, because you are allowed for them to be the same. So 4, 4 is true for that statement there. 4 is less than or equal to 4, for example. Okay, so what's today's lesson about? Well, basically, it's to answer. I'll show you a question I want you to answer. It's from this sheet here, which is from a Corbett math sheet. I don't want you to do question 1, 2, 3. I want you to start on question 4 actually. So these questions here, there's actually 6 of them to do. And what you have to do in question 4 is to basically, on each diagram, put 3 separate lines, all on the same diagram, and shade the region that is met by all 3 of them at the same time. Okay, so you just shade the region that meets all 3 of them at the same time. So you're going to have to plot these lines here. Now, if you're struggling to do that, because you've still not quite got straight lines worked out, I'm quite happy for you to use Desmos today, either as an app or on a laptop or something from the website, whatever, to actually help you to do that so you can see what happens. But bear in mind, if you do it well, I'll show you now. I'll do the first one on here. So, I'm not sure if I can arrange this so you can see what I'm doing and I can type at the same time. Let me just fold this up so I can show you what I'm on about. So there they are. You can type now at the same time. So I delete the one that was there already. So we've got a blank canvas. y is greater than x minus 1. Let me just type that in. So y is greater than x minus 1. Hopefully some of you know what it's going to look like anyway. It's going to look like that. So that's the line y equals x minus 1. I've got to be above it because it's a greater than. There we are. X is greater than or equal to minus 2 is the next one. Oh, what have I just done? I need to click there, I think. There we go. So x is greater than or equal to minus 2. Well, x equals 2 would be a vertical line at minus 2. So x greater than or equal to minus 2 means I've got to be to the right of that line. So I've got to be in that green section there, or that blue section there for the other one. So finally, hopefully this is going to come up in red, y is less than 2. Well, y equals 2 would be a line across there. So y less than 2 will be, oh, I've done it in purple, is below that line there. Notice that they've drawn the line in a dotted. And the correct answer to the question, which is the region where all three of those are correct at the same time, is the place where all three of the colours overlap each other. And that's this triangle here. In this triangle here, you're in the green section, you're in the blue section, and you're in the purple section. Now, it might actually pay you to do something slightly different to what they're doing here, and that's to shade the bits that you don't want rather than the bits that you do want. Unfortunately, I don't know if you saw me checking earlier, I was trying to see if there's a way of doing that on Desmos, but I don't think there is. Some programs will let you shade the wrong region rather than the right region, and then the bit left, the bit that's left white, is the bit you actually want at the end of the question. But that doesn't work on here. So when you're doing it, I wouldn't shade in the correct regions, I'd shade in the wrong regions, and then you'll get left with a nice white patch in the middle, which will be the answer to the question. So that's what I want you to do. I want you to try and do that for each of, I've done the first one there, each of these questions here. Now, if you've got access to a printer, you can actually print out, I've got them here somewhere, some templates to actually put your answers on. Here they are. No, they're not. Where have they gone? Bear with me. 3G. Oh, do they not actually give you templates for this? Oh, that's strange. Okay, then you're going to have to draw the grid out for yourself to do it for each of them. Well, having said that, oh, here we are. You can use these templates. They are supposed to be for question 1, but it's the same grid. So you could use these templates here from question 1 if you're able to actually plot it all out. Print this out. Print out this sheet here. This is the only sheet you really need to print out. And then you can actually do them on there. Otherwise, you're going to have to draw them in your book, I'm afraid. Okay, there's no way around it. You're going to need a diagram for each of these 6 questions here in order to do that work. Now, the second question I'd like you to do is question 5, which is this one here. Now, for question 5, you don't have to draw anything. You just need to be able to work backwards, having got the diagram, to what the original expressions were. Okay, how many of these are there to do? There's 5A, 5B. Oh, it goes all the way up to F. Right, so I will do F now to show you how to do that. And then you can perhaps try the other ones for yourself. So let me have a go at F and see if I can do that one. And then you can have a go at the other ones for yourself. So I'm gonna move the camera in a bit so it's nice and big. Focus on that there. Right, so you are looking at 3 lines that have led to a region, this bit here, which is true for all 3 lines at the same time. So what I need to do is I need to take each line in turn and try and work out what its equation was, and therefore what the inequality was that's being represented by being a certain side of the line. So let's start with the dotted one. Now the dotted one, as it's a dotted line, it will have a greater than or a less than sign, and not a greater than or equal to or less than or equal to sign. The other ones will. So just look at the dotted line, okay, and I'm going to see if I can work out what that line is from where it crosses the axis here and from the gradient the line is on. So I can see it crosses at 2.5, so I know it's y equals something x plus 2.5. Let's write it up here. So it's y equals something x plus 2.5. And the something here is the gradient of the line. So to find the gradient of the line, I need to draw a triangle. Draw it on the diagram, or you can do it in your head. I'm going to draw it in a triangle. I'm going to go from -1 to 1 across the bottom there, and then up to the top there, like that. Okay, and I can see that that is 1, 2, 3, 4, 5, 6, 7, 8, 9, and that is 2 from -1 to 1, 2. Using the scale, not counting the squares, it's 2. So the gradient is 9 divided by 2, which is 4.5. Can't fit it in. Didn't know it's going to be a decimal. So that is the line y equals 4.5x plus 2.5. So in terms of the inequality, well, because it's below the line that I want to be, it's going to be y is less than or not equal to, sorry, because it's a dotted line, y is less than 4.5x plus 2.5. There we are. I've done that line there. That's sorted. That's the first part of my inequality. Let's do this line here then. I reckon I might be able to do this one without drawing a triangle on there. This is clearly the line y equals something x plus 2 because it crosses at 2. Now if the gradient, 1 across, 1 unit across, meant up 1. I know it doesn't look like it's going up, but it's because the scales are different. But 1 across was 1 up. Therefore, if I draw a triangle, I'll just show you. If I draw a triangle on there, that's 1 and that's 1. 1 divided by 1 is 1. So that is the line y equals x plus 2. Okay, so let's just see. I'm above the line, so y has to be greater than or equal to x plus 2 for that line there. And finally, the last one is this one here. And I can see it crosses at 5, so it's definitely, do it over here, y equals something x plus 5, like that. I just need to get the correct gradient. Well, it's going downhill, so it's going to be a negative gradient. And if I draw on a triangle, let's do the triangle here, like that. I can see that that's 2 across there and 1 up there. So it's going to be 1 divided by 2, which is a half, but it's going down, so it's minus a half, or minus 0.5 x plus 5. I am below the line, so it's going to be a less than or equal to 1. So it's y is less than or equal to minus 0.5 x plus 5. That is how you do it. That's quite a hard one, obviously. Okay, and what I definitely want you to do is to nail question 4 using Desmos if you need to, and then hopefully some of you will have a go at question 5, A, B, C, D, and E as well. You can get the answers from Mr. Corbett by clicking on the link at the bottom of the web page here, or if you want some help from me, please just contact me and I will do my best to aid you. Hope that's clear on what you need to do today. Have fun, everybody.